Okay, hello dear students. Today we are going to discuss a new topic, that is addition of vectors. In the last class we have studied about what is a vector, how to represent a vector, and what are the different types of vectors. All those things we have discussed in the last class, and now we have to discuss how to add two vectors. Okay, so normally to add two vectors, at least two vectors of same nature is required. Okay, for example, I can tell you, suppose I am having a vector. A vector means I am taking an example of force. A force of 5 Newton is acting on one of the bodies, and another force of 10 Newton, another force of 10 Newton is acting in the same body. Okay, then how much will be the total force experiencing by this body? Total force experiencing will be 15 Newton, right? 15 Newton, and that 15 Newton will be in the forward direction. Okay, so how do we get it? We'll be normally adding these two forces, 10 Newton and 5 Newton, and the direction of these two will be the direction of the resultant force. Okay, so what is the minimum requirement to add two vectors? Means we require two vectors of same nature. I am adding force and force here, right? I cannot add velocity and force. I cannot add acceleration and momentum. I can add velocity and velocity. I can add force and force. Okay, so I require two vectors of same nature for addition of vectors. Okay, so if two vectors of same nature is acting in the same direction, then the resultant force or the resultant vector will be also in the direction of the original vectors, and the total magnitude will be the sum of the two vectors. Okay, so this is what is the thing. Now suppose these two forces are acting in the opposite direction. Suppose a 5 Newton force is acting in this direction and 10 Newton force is acting in this direction. Then how much will be the resultant? Resultant means the sum, total effect. How much will be the resultant? Resultant will be 5 Newton only. Okay, because these both are in the opposite direction. If the vectors in the opposite direction is to be added, then we have to subtract the less vector from the big vector, and the direction will be the direction of the big vector. Okay, so we have to subtract 5 Newton from 10 Newton. The answer is 5 Newton, and the direction of the big vector is towards left side, right? 10 Newton is acting towards left side, so 5 Newton is acting towards left side. Okay, here the total sum of two vectors is 15 Newton, and that will be acting in the towards right direction. Okay, so this is the case when two vectors are in the same direction or in the opposite direction. Okay, and there have some other cases like two vectors are not coming in the same direction or not coming in the opposite direction. This both of the vectors are making an angle other than 0 and 180. This is, in this case, both of the vectors are making an angle 0, right? And in this case, both of the vectors are making an angle 180, right? So there have situations in which two vectors are making the angle other than 0 and 180, right? So on those cases, we are using some laws, some theories to add two vectors. Okay, so among that, the first one is triangle law of vector addition. Triangle law of vector addition. Okay, triangle law of vector addition, right? So to understand triangle law of vector addition, first of all, let me tell you what is a statement of that law. If two vectors can be represented both in magnitude and direction by the two sides of a triangle taken in the same order, it's very important, then their resultant is represented completely both in magnitude and direction by the third side of the triangle taken in the opposite order. You might have confused by seeing this big definition or big statement, right? Don't worry, I'll explain it to you in simple words. Okay, suppose I have to add two vectors. Okay, suppose I have to add two vectors, and the first vector is this. Suppose I have a vector A. I am giving the name A for this vector, and I have another vector. This is B, vector B. I told you that we have to put vector sign over this letter, then only it will become vector. Otherwise, it will be a scalar quantity. So A, this is vector A, and this is vector B. Okay. Now suppose I have to add these two vectors by using triangle law of vector addition. Okay, so first of all what I am doing is I will be placing these two vectors in a particular arrangement. Okay, so what is that arrangement? I'll tell you. First of all, I have to take the first vector. First vector is vector A, right? So I am going to redraw this vector A in some other place here in the same direction and in the same magnitude. Okay, that is very important. Same direction and a same magnitude. Okay, so this vector and this vector is having same magnitudes. Magnitude, how do we can represent? By using the length of the vector, right? This length and this length is same. Okay, and this direction and this direction is same. So this is vector A. Okay, and vector B is there. How do I am representing this vector B is this vector B's tail is there. This is the tail, right? And this is the tail of vector A. This is the head. Head is the part in which the arrow mark is present. This is head of vector B. So what I am doing is I am placing the tail of vector B on the head of vector A. Okay, and one thing you have to remember, you should maintain the same magnitude and same direction of B also. So I'm taking the vector B from here and I am placing the tail of vector B on the head of vector A. Okay, so like this. So it will come like this, right? It will come like this. Okay, this is vector B, right? Now I have represented two vectors as two sides of a triangle. Okay, now if I am completing this as a triangle by drawing the third side of this triangle, see how much part of this definition we have completed now. If two vectors can be represented both in magnitude and direction by the two sides of a triangle taken in the same order, that same order is what? See, this is the direction of first vector and this is the direction of the second vector B. So in the same order, right? In the same order, or the direction is continuing. The direction of B is like continuation of the direction of A, right? In the same order. Okay, that is what is the meaning of same order. We should not put the head of the second vector here. We should put the tail of the second vector on the head of the first vector. So that much we have completed. Then their resultant is represented completely both in magnitude and direction by the third side of the triangle taken in the opposite order. So the third side of the triangle will be giving us the value of resultant. Resultant means the sum or the total effect. Okay, so the third side of the triangle is this, right? And one more thing you have to understand, this should be taken in the opposite order. Opposite order means not in this order, not in this. If this is in this order, I have taken the third side of the triangle in this order, the head will come here, right? Okay, the arrow mark will come here, but the arrow mark will come here. Okay, so this is in the opposite order. This is actually the order of vector A and B, and this is the opposite order of this order is opposite to the order of A and B. Okay, so this will be giving us the value of resultant. I am putting R for the resultant, vector A plus vector B. Okay, so this will be giving us the resultant. So this is the way in which we are representing the resultant or finding the resultant of two vectors by using triangle law of vector addition. Okay, so this can be done in any cases means in if you are getting any two vectors, you can use this method. Okay, suppose I am having two vectors, this is vector A, and suppose I am having another vector, this is vector B. Okay, now how can I represent it? See, I am placing first vector A in the same direction and same magnitude, and second vector, when I am representing the second vector's tail have to be placed at the first vector's head. Okay, so it should be placed like this. Okay, so this is vector B, this is vector B. Now how can I find out vector A plus B? Vector A plus B will be the third side of the triangle. This is vector A. Okay, so this will be the resultant. What will be the direction of the resultant? This is the order of A and B, right? So I should not put in the same order, but in the opposite order. Okay, opposite order. Okay, So this will be r is equal to a plus b, right? So this is the way in which I am representing or I am explaining the direction and magnitude of the resultant vector using triangle law of vector addition. Okay, now if you are taking b plus a, what will be the change happen? Suppose I'm taking b plus a. So if I'm taking b plus a, I'll be placing b at first. Okay, b vector I'll be placing at first, and after that I will be placing vector a. Vector a is see, vector a's tail I am bringing into the head of vector b. So like this it will be, this is vector a. Okay, so now the vector b plus a, who will be the resultant? The resultant will be this, right? Resultant will be this. This resultant will be in which order? Opposite to this order. Okay, that means in this, right? So this vector r is equal to b plus a, vector b plus vector a. Okay, anyway these both are same. Vector a plus vector b is equal to vector b plus vector a. See, the magnitude of this and this is similar, right? Similar length. These both are having similar length. If I am taking this length also similar to a and b of this, these two third sides will be similar length, and also the direction is also similar. See, the direction of this is this, the direction of this is also similar to the previous one. So we can say that resultant vector a is equal to a plus b, which is equal to b plus a. Okay, so we can write it like this: a plus b is equal to vector b plus a. This is actually commutative property. Okay, commutative property. If you are interchanging it, there won't be any changes in the magnitude and direction of the vector. So this is the way in which we are finding the sum, or we are adding two vectors, okay, using triangle law of vector addition. Okay, so I hope it is clear to you what is triangle law of vector addition, right? And now we are going to explain about the very important second method of addition of two vectors, that is parallelogram law of vectors. Okay, parallelogram law of vectors, right? So in parallelogram law of vectors also will be providing the same answer as we have got in triangle law of vector addition, but this is a different method, that's all. Okay, answer will be same. Both of these are resulting in the same answer, that I'll show you that. Okay, right. Now let us go for the definition of parallelogram law of vectors. See, what is the definition? If two vectors are represented by two adjacent sides of a parallelogram, then their resultant will be represented by diagonal passing through the common tail of two vectors. I'll explain for you clearly. Suppose I am having two vectors. As I have considered earlier, I am considering two vectors here also. Okay, so one vector, okay, I can consider in any direction, no problem. Suppose I am considering one vector a here, and I am considering another vector b here. Okay, right. Now what I am doing is, if two vectors are represented by two adjacent sides of a parallelogram, you know what is a parallelogram? This is a parallelogram, right? Parallelogram means opposite sides are parallel and are having equal length, right? So adjacent sides of a parallelogram means this side and this side are adjacent, right? And this side and this side are adjacent, this side and this side are adjacent, this side and this side are also adjacent. Adjacent side means the nearest sides, right? Okay, now if I am representing these two vectors a and b as adjacent sides of a parallelogram, how do I can represent it? First of all, I am representing vector a. I am drawing it separately at all, right? So vector a, I am representing it like this, right? And after that, what I am doing is, I am placing the tail of vector b in the tail of vector a. Okay, in the case of uh, triangle law of vector addition, we place the tail of vector b on the head of vector a, but here things are opposite. The tail of vector b will be placing on the tail of the vector a. Okay, so I can represent vector b like this. Yeah, vector b I am representing like this. Okay, now if I am completing this as a parallelogram, by providing the other two sides, it will comes like this. Yeah, it will comes like this, right? So this is a parallelogram now, right? I can give PQRS name. So this is a parallelogram. Two adjacent sides are a and b. Okay, right. So A and B are two vectors. And now the diagonal which is drawn through the common tail, okay, common tail diagonal, two diagonals can be drawn, but the diagonal which we are considering is the diagonal which is passing through the common tail, okay, or which is starting from the common tail of two vectors. This is the diagonal, right? This is the diagonal, okay. So the direction of the diagonal or direction will be this, okay, right. So this will be providing us the resultant vector. Resultant vector means addition of A and B. You can write A plus B, okay. So A plus B will be the diagonal which is drawn from the common tail or from the common junction of two vectors, okay. So this from this, so this diagonal will be providing as the resultant vector, okay, right. So this is generally, this is actually equal to the previous principle, right? Previous triangle law of vector addition. How do I can say that this is similar to triangle law of vector addition? See, this is a vector A, and see, this vector or this side is also in the same length of this and these are having same length, because in a parallelogram this both the opposite sides will be having equal length, right? So this I can consider as equal to A, okay, this I can consider as equal to A. And see, this side is having equal length to this vector, right? So this I can consider as B, okay, having same direction. So this is equal to B and this is equal to A, okay. I'm just redrawing it because this picture didn't come as correct, okay. Yeah, vector B, vector A, okay, and here also I'll be having vector A, and here this is vector B, okay, vector B, right. So I told you that the diagonal is the diagonal which is drawn from common tail to the common head, or heads are meeting here, tails are meeting here. So this is providing us the resultant A plus B, okay, A plus B. Now you can compare this with the triangle law of vectors. You forget about this side, forget about this half, okay. Now this is a triangle, right? Now this is a triangle. In this triangle I can give name for this. This is P Q R, P Q R S, okay. Now if I am forgetting about this part of the parallelogram, now PQR is another triangle. You see, this vector A and vector B are two vectors which have taken in the same order, right? In the same order. Then the diagonal, forget about this part, okay? Forget about this part. Then the diagonal is actually the third side of this triangle, right? Diagonal is the third side of the triangle which is taken in the opposite order. Opposite order means not in the order of these two vectors, in the opposite order. If I have taken the diagonal in the same order, the direction would have come from here to here in this direction, right? But it is not happening. We are taking the direction of this in the opposite order of vector A and vector B, okay. So if you are considering the half of the parallelogram, this is actually triangle law of vector addition. And if you are forgetting about this triangle will be providing us the same answer, because this is B, this is A, and this diagonal is taken in the opposite order of A and B, right? Opposite order of A and B, and this will be giving us the value of R is equal to B plus A. This because B plus A is this one, right? B plus A, but A plus B is equal to B plus A. Vector A plus vector B is equal to vector B plus vector A. So whatever it may be, it doesn't matter. If you are reversing the order A plus B or B plus A, it doesn't make any change in the final answer, okay. So this is what is parallelogram law of vectors. So how we can define parallelogram law of vectors, I have already explained you. If two vectors are represented by two adjacent sides of a parallelogram, see, two vectors, this is vector A and vector B, both are adjacent sides of a parallelogram, right? then their resultant will be represented by diagonal passing through the common tail of two vectors. Common tail passing through means which is initiating from the common tail, which is initiating from the common tail, okay, which is start from the common junction, right? So that diagonal will be giving us the value of a resultant. Okay, resultant means what? Resultant means the sum. Okay, sum. Why do we are considering these geometrical shapes and all here to find out the sum? Why can't we directly add vector A and vector B? Because these are not scalar quantities, these are vector quantities, because the directions are involved. Directions have a major role in determining the sum of two vectors. Okay, so direction have to be considered. But if someone is asking you what is 10 kilogram plus 20 kilogram, we can say that this is 30 kilogram. We don't want to mention direction. But if you are adding two vectors which is having direction, then we have to consider these geometrical methods like parallelogram, triangle and all. Okay, right. So these are the two major methods we are using to add two vectors of same nature. Okay, right. Thank you.